In last lesson, we were studying about alternating current and different ways of representing it, and we ended when at rectification. Now, what is rectification? It is conversion of alternating current to direct current, and in order to do that, we use a diode. Diode is a combination of two semiconductors, P-type and N-type semiconductor. They are sandwiched together and they allow current to move in one direction. This is diode. It only allows current in one direction. If you look at the shape of this thing, this symbol, it will look very much like an arrow.
Yes, sir.
And these arrows are pointing towards right?
Yes.
Just one second. Now, here we have three images. The first one is just for the information, like this is the graph for voltage and current. This one is voltage plus volts minus, this is current. This is current negative. So there is no current and then there is constant current like this. So diodes only allow current in one direction. When you change the potential difference and you want the current that is not supported by the direction of diode, then diodes don't allow the current to pass through. So this situation, diode is forward biased, and this means diode is reversed biased. Now, what is forward biased and reverse biased? Look, if this is a diode, and I told you just a minute ago, the diode, the symbol of the diode very much looks like an arrow that shows a direction. So this is pointing towards right. So that is the direction of this diode. If current is going this way, this is the direction of the current. Do you think the direction of current agrees with the direction of the diode? Yes, it does. So this current is allowed by the diode. So it is forward biased. Ideally, no resistance is offered and diode behaves like a closed switch. Okay, it will allow the current like it is not even there. Okay.
Sir,
But
ideally no resistance is offered. और आपने क्या लिखा हुआ है?
ideally, no resistance is offered. ideally. Like in reality, diodes do offer a small resistance. If there would be no resistance, then this current should go to infinity with a small potential difference, but it is not. So the reciprocal of this
Mhm.
gradient will be equal to uh, resistance.
The
That means
resistance, yeah.
resistance is not zero. Resistance is not
So could
zero.
you just show me the text that you've written about? And that way I could post it. Okay, thank you. Yeah, got it. Yes, I got it.
Ideally, no extra resistance is offered. Now, what if current is going in the other way? Like current wants to go this way. Do you think this direction agrees with the direction of the diode?
No.
So diode will not allow this current to pass as this diode is reversed biased. In such case, diode offers infinite resistance. Again, this is an ideal statement. Diode acts as an open switch. Does this make sense? So diodes only allow current to go in one direction. This is from the previous year's syllabus. We discussed that in AS.
Sir, in that figure number two, if the current is moving according to the diode position, then there would be nothing to stop the current, right?
Like diode will act like it is not even there.
Okay, it's just going with the flow, right?
Yeah. There will be no extra resistance offered, and there will be no effect because of the diode. If there is a wire and wire is offering any resistance, then that resistance will be the resistance. And this diode will act like it's not there. It will behave very much like a closed switch. Now, we will use this to change the direction or pattern of alternating current. Here we go. We have this voltmeter which is connected parallel to a lamp. This lamp is connected in a circuit. The symbol for alternating current is like a wave. So this is a lamp. This is a voltmeter. So what will happen in this case? Now, if we record the reading on the voltmeter, we should expect this. Okay, we should expect this. This is voltage in volts, and this is time in seconds. So when there is an alternating current, this is what we should expect. What if I redraw the circuit, but this time I put a diode over there? I can put diode anywhere, but I'm putting it here. Here we go. This is a diode. And now, what will happen now? Half of the time current goes like this, which diode is okay with it. But when current changes its direction and wants to go this way, the diode stops it. So current can only flow in one direction, and when current changes its direction, diode will stop the current. So what you should be expecting is this. There will be a reading in one direction, and then this is when diode is forward biased. And when diode is reverse biased, there will be no EMF, sorry, no reading on the voltmeter. Okay, so half of the time the diode is forward biased, half of the time it is reverse biased. When diode is reverse biased, it is not allowing the current to pass through. So how is this second diagram different from the first one? Look, in the first diagram, in the graph above, current is voltage is sometimes positive and sometimes negative. But in the graph below, there is positive voltage and there is no negative voltage. So voltage is only in one direction. So that means an AC is being converted into DC. This is AC being converted to DC, direct current. Okay, it is not a constant direct current, but yes, it is a direct current because it is not changing its direction. So this is called just 1 second. Now, this is called half cycle rectification. This is half cycle rectification. Now, for full cycle rectification, what we do for full cycle rectification? Now we need a full cycle rectification. Oops. Now, in this rectification, just 1 second. Okay. In order to do full cycle rectification, I'm taking the same diagrams, but in this case, what we do is we connect a capacitor parallel to the output resistance. In this case, the lamp. So this is a capacitor. When diode will be forward biased, it will be allowing the current to go into the, like, it will be allowing the capacitor to get charged as well. And when alternating current will be reverse biased for the same diode, it will stop the current in the whole circuit, but the capacitor is already charged. So capacitor will start to discharge itself in the meanwhile. So if we control the resistance of the output circuit and the time constant of the capacitor, we can get this thing going on. Okay, when there will be this gap, the capacitor will be providing energy to fulfill that gap. So this is called full cycle rectification. Full cycle rectification, where there is no gap. Look at the half cycle rectification. There is a half cycle of gap over there. But now, one more rectifier. We call it bridge rectifier.
Excuse me, sir.
Yep.
Sir, on half-life rectification on the second diagram, you are using both the condition at the same time, like doing the forward and again doing the backward direction.
Sorry, what are you talking about?
In half cycle rectification,
Yes.
in the second diagram, like you are using the first forward direction and then using the second condition at the backward.
Yes, yes, yes. Obviously, when current, like, do you see alternating current? Have you ever changed batteries in a remote control, Dapish?
Yes, sir.
So when you change batteries in a remote control, do you pay attention that which side of the battery is positive and which side is negative? And in the compartment for the cell or batteries, do you focus on where should the positive go, where should the negative go, or you could just put the batteries in?
No, we see the sides.
But when you're plugging in your charger or mobile charger into the socket on the wall, do you bother to see which side is positive and which side is negative?
No.
How come? If it is a current, it definitely has a positive and negative. That is how the current works. Then why don't you give a second thought, or why don't you consider which side should go where?
Okay, sir, I got it.
What? I didn't explain anything. I'm just asking you a question. My question is that why don't you bother when you're plugging something in the socket, but you have to be extra careful when you're putting batteries in a remote control, because if you put them the way they should not be, the remote control will not work. So why uh, different approach for different situation?
Because it is a mm,
Because the batteries that you put in a remote control, that is a case of direct current where there is a
direct
positive
current and
side
that
and
is
there's a
of
negative.
alternating current.
Yes, the sockets have alternating current, and alternating current means, look at the screen now. If uh, this side is positive right now and this side is negative, after half of a cycle, this will become positive and this will become negative. And then again, this will become positive and this will become negative. They will keep switching one. You know, the alternating current that is in your room right now is changing its direction 50 times in 1 second.
No, sir, I don't know that.
But now you should. It takes about 0.01 second for positive to become negative and then negative to become positive. They keep on switching from one to another and another to another. So when this side is positive and this side is negative, current wants to go like this, and diode will allow it. Because I hope you can see that the current's direction is agreeing with the direction of the diode.
Yes, sir.
But when current will be going like this, do you think the diode will allow this current?
No.
The whole circuit will stop working. The diode will stop the current, and you will have a gap portion over here. The diode is reverse biased. This is diode is forward biased. And this is diode is reverse biased. Okay.
Sir, I have a small question. Like, you in our home, like we do have alternating current, right?
Mhm.
So in full wave, in full rectification, how does it work in like capacitors? Is there a capacitor?
Like in this is the one you're talking about now.
Yes, sir. Like the EMF is
Like
sorry.
when diode is forward biased, for example, like this, the current will go into the lamp and as well as to the capacitor. Will it?
Yes, sir.
So capacitor will get charged as well. So when direction of current changes and current wants to come the other way around, the diode will stop the circuit and there will be no current from the supply that will be working in the circuit. So just 1 second, I'm back. So when diode is forward biased, the capacitor gets charged as well as there is current passing through the lamp and the voltmeter is reading a potential, electric potential. So when diode becomes reverse biased and the supply changes its direction of current because it is alternating current, diode will stop the current. But in that time, the capacitor will start delivering stored energy into the lamp. Okay. So that is the time capacitor is fulfilling those small gaps over there.
Sir, as of a small question, like in our household, like if there is a power cut and we are using the inverter, and as an we can take the inverter as a capacitor, right?
No,
No, I think like the stores.
inverter is only a device that converts direct current into alternating current. Like alternating current has so many advantages. We can produce it with mechanical methods, and we can produce it with any kind of rotation. There are so many advantages of alternating current, but there is one problem. We cannot save alternating current. Alternating current cannot be stored.
It is just being the conversion.
Sorry.
We are just converting it, right?
We need to, if we need to store alternating current, we need to convert it.
Yeah.
Just 1 second. Okay, now I'm making a bridge rectifier. Okay, now these are diodes. This is the alternating current supply. Okay, this is alternating supply that we provide over here. So there's a resistor over here. There is this voltmeter. This can be a voltmeter or a CRO, because CRO can not only record the voltage at a particular instant, it can also keep the record of the previous voltages and give you the variation of the voltages over time. So let's use voltmeter for now. This is resistor. This is point A. This is point B. Okay, these are the diodes. Okay. Now See carefully. If this side is positive right now, this side is negative. So current has to leave this terminal like this. And if it can find its way back to the negative terminal, it means we have put every diode in the right way. Look, if the current goes over here, the first junction is here. Let's name it X. When current comes to X, there are two ways the current may go. One is up, the other is down. At X, what do you think? What should be the direction the current should go? Up or down?
Up.
Because that diode is supportive to this current. So current will go and it will reach Y. At Y, either the current can go towards the resistor or it can go on the other loop because there's another junction. So what do you think? What is the option for the current to go?
To go with resistor.
To go towards the resistor. Good. So it will go to the point A and then it will go through the resistor, go to point B, and then it will come back to junction Z, where it is supposed to go to the negative terminal. So should it go to the left side or the right side?
Right.
So it will reach W point. So at W, should it go towards Y or down?
Y.
At W, should it go towards Y or should it go down? Remember, it has to go to the negative terminal to complete the circuit.
Negative, negative.
So it will go down. And if everything is right, let's see, the right side becomes positive and left side becomes negative. What will happen now? The current will leave the positive terminal of the battery and it will reach the point W. When it gets to W, it has two options: go towards Y or go towards Z. Where will the current go?
Y.
Current will go towards Y. At Y, it will go towards A and then it will go to B, and at B, it will come back to Z. At Z, it will go to X and X to negative terminal of the battery, completing the circuit. So whatever the direction of the or potential on the terminal is, whether the right side of the supply is positive or the left side is positive, the current is going from A to B for the resistor. So current is still moving in the same direction. So for this one, let's make a this is the voltage of the supply. Voltage of the supply. Okay, this is good. Now I can see this is how the supply voltage is changing. It is becoming positive and negative repeatedly, like a normal alternating current. This is voltage in volts. This is current in, time in seconds. This is supply. Okay. Now, how the voltage will change for voltmeter V? For voltmeter V. Voltmeter V will not register the same values as from the supply. I think I have increased the voltage without reason. Now, this is what you should be expecting. So at this point, you might ask that this is something already done. Why to make a so danger looking circuit for something that we already achieved? Okay, because this is simple full cycle rectification. But the achievement in this is that we did it without capacitor. Now you can ask that what was wrong with the capacitor? Are capacitors very expensive? Answer is no, they're not very expensive. Then why do we need to do it without capacitor? Question is, what will happen if we put a capacitor in this thing? Like what if we provide with a capacitor? So it's the same thing again, but this time we will put a capacitor inside. Okay, the supply is same. But what will happen if I put a capacitor parallel to the resistor? Oh, the class time is over. We will resume from the same point tomorrow. But if you have any guesses, you can complete the circuit and share your work with me tomorrow. Okay, we will start or resume from the same point tomorrow. Okay, take care.
Okay, sir. Assalamu alaikum. Have a nice day.